Welcome to my work solutions for the Edexcel paper from November 2024 series. As you can see, it's paper 2, Calcs Allowed, so let's get on with it. Speaking of calcs, question 1, I will just say the final answer is 4.643069317. Now the idea of giving you that is because if you get that, you're obviously using your calculator correctly. If you aren't getting that, do make sure that before you square root it, you're actually getting 21.55 and a load of other stuff, 9268. Make sure you are getting that for the stuff that's inside the radical. Now, if you aren't getting that, I would strongly advise sticking brackets around the numerator and the denominator. Then hit equals before square rooting and make sure you use or can use the ANS button on your calculator because it does come in very handy and does come in handy for iteration and other malarkeys later on. On we go. Yep, number 2 I've cheated because I don't trust myself to do my electronic pen stuff, so I've cut and pasted this from my work solutions. Just so you're aware, when examiners mark these, they have these things called gates, which your line must pass through. Now, the mark scheme itself doesn't actually say where those gates are, but that is how they mark it. Now, the good news is they are very generous. You sometimes lose that mark if you don't make your lines long enough. Nothing wrong with making them a bit too long rather be a bit too long than a bit too short and therefore stop early and miss the gates. So do make sure wherever you are you commit and you draw them roughly towards the end or slightly beyond the end of where the data finishes, both at the top end and at the lower end. So when you draw your line of best fit, see-through rulers obviously help, trying to get it balanced, but don't take too long. They are quite generous. Anyway, let's answer the questions. What type of correlation? Only worth 1 mark. Only giving you a small room for an answer, so it isn't looking for you to write a sentence. When they want you to write a sentence, they'll say, describe the relationship. And you'd say, when it's longer, it's wider. When you are asked to describe the relationship, that's when you get those words in. Here, nope, just looking for positive. Part B, that's the bit I've already described. Part C, use your line of best fit. Show the evidence you're using it by drawing your lines on, because if your final answer's not perfect, they always allow follow through. 194 meters, that's where you find it. Straight up to your line, straight left off your line. As you can see, mine's actually coming out at what's that, 25. Yeah, so the whole thing's half a square. So 26, 27. Mine's coming out at 28. And a quick glance at the mark scheme. Mark scheme allows anything between 26.5 to 29.5 inclusive, or they do follow it through from your line of best fit, which again is why you should always draw on it. Number 3, first wordy one of the day. As soon as I see left and right, London and Zurich, I start doing that. Obviously, there's loads of ways of going about this. You could find the value of 1 gram in each. You could convert Zurich entirely to London, London entirely to Zurich. I prefer to play the halfway game. I start with London, and we know what 200 grams is worth. Shouldn't take too much of a leap of faith to say that it's halve it. So in London, 100 grams costs £1.75. And you can take that a stage further, because to convert pounds to Swiss francs, you multiply by 1.25. And we get that in London, 100 grams would cost the equivalent of 2.1875 Swiss francs. Let's go to Zurich. Same process. We go for 100 grams from 360 to 100. Your scale, your multiplier, or in this case, our dividing number is 3.6. Find your scale factor. Do 360 divided by 100. You get your 3.6 if you didn't see it straight away. Divide 7.2 Swiss francs by 3.6. That means 100 grams is 2 Swiss francs. As you can see, you've now got a pretty straightforward comparison. In which city is it better value for money? Straight away, it's Zurich, because 100 grams costs 2 Swiss francs, but in London it'd be well over 2, almost 2.2 Swiss francs. Number 4, what's Tom done wrong? Now you can use your own words and phrases. You could obviously correct things. He's got 17 in 2 places. 17 should only be in the middle or the intersection, would be my first reason. And also, he's supposed to be dealing with all the odd numbers from 1 to 20. He's missing the lowest odd number. He's missing the digit 1, so he needs to add 1 into the diagram. Feel free to do it for Tom like that. Don't overcomplicate. Don't feel like you've got to write, or is it 656 lines? Nope, none of that. Number 5. Obviously, because I cheated for the scatter diagram, I was always going to cheat for this. When you're sketching it, you've already got 2 to sketch. The diagram is always symmetrical. You can always look for symmetry in your table as well. First of all, always sub in the easy numbers. So your 1s, your 3s, your 4s, but absolutely your 0 is the easiest to first of all sub in. So start there and work to the right. Sub in 0, 0, 0, minus 3. There you go. You've got your line of symmetry. The minus 3 and the minus 3, that makes the 0 reflect up here. Let's sub in 1. 1 squared minus 2 1s minus 3. We end up at minus 4. And we don't need to sub in the negative 2 because the answer down here and the answer up here will be the same. So just do it for 4. 4 squared minus 2 4s minus 3 means a 5 goes in there, a 5 goes in there. That's where those coordinates have come from. Obviously now you get them plotted, treat them like a series of plotting coordinates. Do not use your ruler, put that down. Meant to be a smooth curve going through all the points. They do allow plus or minus half a square all the time. So the odd little bit, don't get too worried about the odd, yeah, mine's not perfect, I miss it by a little bit. Trust me, examiners would be fine with that. Try and get it better than mine, but mine would get the marks. On we go. Number 6, another one of them slightly wordy ones, one thing at a time. We've got the cost, first class stamp, etc., second class stamp, and so on. Philip says the percentage increase. Stop right there. Let's do the first class percentage increase. The formula for percentage increase is actual increase, which is 9 pence, divided by original amount, which is 76. You times it by 100, and round it off appropriately. 11.8-ish%. Let's do the same for second class. It's only a penny is the actual increase. The original is 65p. Same again times by the 100. And we're getting out roughly 1.53%. It goes on. You're nearly there. That's where we stopped. The percentage increase is the cost of a first class stamp is more than 7 times the percentage. If we take our 1.5 and we times it by 7, we get 10.77-ish%. Is Philip correct? We can categorically say yes, Philip is correct, because as you can see, 11.8 is indeed greater than 10.77, or words to wrap it up to that effect. On we go. Number 7. There are two ways of going about this, two ways of finding x. You could add up all three sides, simplify, put it equal to 72, and you'll get x equals 7.5. Or I've chosen to go for the fact they've put the notches on there, which make this an isosceles triangle. I'm going for 2x plus 11 and 4x minus 4 must be the same length. I'm going to take 2x from both sides whilst adding 4 to both sides, and no matter which way you do it, you get x to be 7.5. But that's not anywhere near the right answer. It wants the area of the triangle. Using a bit of logic, area of this triangle would be the length of the base. The base has the expression 2x plus 5, which will mean 2 lots of the x we've just found. That makes 15 plus 5. We get the length of the base to be 20. Let's go back to our area. A half of the base times, we now need the height. This height, we actually need to use a bit of Pythagoras, because we actually do have the length of the hypotenuse. It's 4 lots of 7.5. Take away 4, the hypotenuse is 26, which you'd also get if you went for the left-hand side, also 26. The base we know is 20, but if we're going to apply Pythagoras, we're only using half of it. The height, Pythagoras is the square root, is the hypotenuse squared minus the shorter side squared, giving us a nice answer of 24, and we're pretty much there. Height is 24, stick it in your calc, area of that triangle is 240 centimetres squared. Number 8, just worth taking a moment to remind ourselves that if 8 equals k times 4, your brain just tells you that k has the value of 2. But where did it work that out? You divide by the 4. And if that works for easy numbers, it's going to work for tricky numbers, even numbers in standard form. On your calculator, you should be finding k by pressing 1.25 times 10 to the minus 12. And same as what I said for question 1, if you don't agree with my next bit of the answer, do make sure you put some brackets around the numerator and the denominator. And now divide by 4 times 10 to the power of minus 20. And if your calc gives MA error, by the way, do take care that you don't put the bracket in the power. You need to press the right hand on your kind of joypad, D-pad, cursor, whatever you want to call it, to make sure you bring the bracket down on the level of everything else. All that in your calc should be spitting out 31,250,000. We've got to convert it to standard form. To be a number between 1 and 10, we'd like the decimal point to be after the 3, which makes it 3.125. But how many times has decimal point moved? 1, 2, 3, 4, 5, 6, 7 times. Makes it power of 7. Or you may be lucky enough just to know that power of 6 would be millions, so tens of millions means power of 7. Number 9. Diagram shows two identical regular 9-sided polygons. When you have a 9-sided polygon, and it's regular, its external angle is 360 divided by the number of sides it has. So that external angle is 40 degrees. That if the external angle is 40, that makes the internal 140. This one's identical, and that tells us that angle ABC is 360 take away 280. Whoops, not 90 degrees, so ABCD cannot be a square. So any words to that effect to wrap it up, you could say should be 90 degrees to make it a square and so on, or however you want to phrase it, doesn't really matter. Number 10, use algebra, just in case you were thinking about picking up your calc and trial and error in it. You could, if you wanted to, make the x's the same, make them 12. You could make the y's the same, make them 35. I prefer to go for as small as numbers as possible, so I'm going to treble the top equation, double the bottom equation, and then I'm going to see that I've got 12 x's in both. Let's go across the top, treble everything, minus 15y and 60. Doubling the bottom, also 12x, positive 14y, negative 114. We're going to do a giant subtract. Top take away bottom, 12x. Why is it a subtract? Because that's a positive 12. That's a positive 12. And I'm sure your teachers have nagged you, same sign, subtract. That's why we subtract. X's, they cancel, they disappear. Use your calc if you hate negative numbers. It's negative 15y minus 14y. Takes us down to minus 29y. 60 take away minus 114 is 60 plus 114. And to find y, 174 divided by minus 29. And when it works out to be a relatively friendly number, you can always have confidence that you're nearly there. Minus 6, in it goes. I'm going to pick the bottom equation. Bottom equation says that 6x's plus 7 times minus 6 is minus 42. Adding 42 to both sides, and dividing both sides by 6, we can give the answer minus 2.5 or any fraction equivalent of. Number 11. This is obviously where you can grab your ruler. It's a different size, so it's definitely an enlargement. You just need to work out the center of enlargement, and there we go. The center of enlargement is wherever these rays cross. So state the obvious. Even though it's going from A to B, we're getting smaller. We don't call it a shrink or anything, it's still an enlargement. We have a scale factor and a center. The center, that's where the rays cross. That's the coordinate -4, -2. And scale factor, simply look at one of the corresponding sides. This top line has gone from 3 to a size of 2. It's gotten smaller. That means that our scale factor is 2/3. Got to divide by the number you've got and multiply by the number you want. Hence 2/3, not 3/2, I'm afraid. On to number 12. Quite a bit that can go wrong in this one, if I'm honest. First of all, they start waffling about densities, etc., etc. Get it written down. Density, mass, and volume. The volume of the cube is h times h times h. The volume of the cylinder is pi times the radius squared multiplied by the height. You're welcome to use the decimal equivalent if you want, but most calcs nowadays will keep it in terms of pi. That's our first job. We've got the volume of both shapes. We are told the mass of the cylinder is equal to the mass of the cube. The mass of the cylinder is 72 pi. That's the volume. We've got to multiply it by the density. The density of the cylinder is 7.86. And this decimal is equivalent to h cubed. That's the volume of the cube multiplied by the density of the cube. And you could type some of this into your calculator, as in 1777 and so on. But for me, do it your own way. Divide both sides by 8.5 and then cube root your answer. You should be getting 5.93 and so on. You're told to do one decimal place. Always do as you're told. 5.9. Number 13. Nadia says that y is directly proportional because as the value of y increases by 4, the value of x increases by 2. And the idea being, if you were to plot these on a straight line on a set of coordinates, you'd get a straight line graph with a gradient and so on. That would mean, is Nadia correct? Yes, she is, as both are increasing. Because even if it looked a bit like that, which comes into play down here, it's still direct proportion. It's just direct to things like the square root or other things. Similarly, you can have direct proportion to cubes and so on. So at the end of the day, it's direct because they're both increasing. Oops. So yes, both are increasing. Next, w is directly proportional to the square root of t. Get it written down. W equals a constant times root of t. We're told W is 140, in it goes, when t is 64. Root of 64, and there we go. We've got our value of c, or you might have used k. Whoops, 17.5. Reset, start again. W equals this constant multiplied by the square root of the value of t. Get it stuck in your calculator. Out comes the 49. And as I mentioned for part A, this is direct proportion, says it in the question, but it's about square root. If you've never sketched the diagram of the square root, it's one of them that's worth learning. It follows that general shape. It's basically that, but it's been reflected, but we only look at the top half of it. So that's what the graph of root x looks like. On we go. In 14, absolutely loads of ways of doing this. They've given you bags of room if you want to write it all out, but why bother? At the end of the day, if there are 10 teams, they must play each other. So for all 10, the first team must play all 9 other teams. Then they're kind of out of it. Then there's 9 teams left. 8 games, 7 games, 6, 5, 4. Now, if they only played each other once, that would be your total. Add them all up. But they don't. They play each other 4 times. Get it times by 4, and your 55 times by 4, 45 times by 4 comes out at 180 games. On we go. Number 15, we've got quadratic nth term. First of all, look at your differences. We've got up by 17, 27, 37, and 47. Our second differences, it's going up by 10, 10, 10. There's your first clue. The idea being, if you get a constant at the second difference, it's an n squared term, it's an n squared sequence, but whatever digit you get here, it needs halving. I always prefer to write out this sequence directly underneath, so we need our square numbers, but times them all by 5. So 1 times 5, 4 5s, and so on. 45, 80. Now what do? We need to have a little reset. We know that 5n squared is in our answer. What do we need to look at? Take your sequence, the 3, the 20, the 47, subtract the 5n squareds. 3, take away 5. 20 minus 20. 47, take away 45. And you should, at this stage, notice a much friendlier pattern going on. It's almost like a mini reset now. You now need to do the nth term of this sequence. It's going up in 2s. So 2n, the 2 times table, is part of the sequence, 2, 4, 6, 8, 10. And from there to there, there to there, it's down by 4 each time. On we go. The terms of a different sequence is given I know people don't like this. It's called the inductive definition. They don't like this terminology. Just read it to yourself and say that what it really means is to get the next number, you substitute in the current number. That's it. In other words, to get the next number, which is 4, we sub in the current number. The current number is the first number, 9. Okay. Well, hold on. We can solve this. We can add our k's together. And we can divide both sides by 10, which can be 2/5 or 0.4. It's entirely up to you. We're being asked, though, for the fourth term in this sequence. Well, before you get the fourth term, you're going to need the third term. You get the third term by subbing in the second term, which is multiplied by k and add k. Out comes the digit, the number 2. Repeat. To get the next number, the 2 goes back into this function. That needs multiplying by 0.4, and we add 0.4. Once we've got all that, calc says, or mental arithmetic says 1.2, and you're ready to move on. Number 16, we've got a bit of histograms with a bit of words going on. First of all, doesn't really tell us a great deal at the top, apart from the histogram should represent 60 teachers. All the bars should add up to 60. 11 travel between 0 and 5. In it goes. Doesn't tell us about the other 2 bars. But hold on, it didn't need to tell us 11. We can work these out because frequency in histograms is the area of each bar. So the area of this bar is 10 wide, 1.5 high, 10 times 1.5. And for the second bar, 20 wide, 0.3 high. There we go. The 3 bars we are being told about have a total of 15, 26, 32. The other 2 bars that are missing will represent 28 teachers. None of the teachers travel greater than 50. Great. The number of teachers for this bar is the same as the number of teachers for that bar. Or in other words, 14 for each bar. Each bar must have an area of 14. So how do we find the height? We do 14 divided by the width. So the width of this bar is 5. 14 divided by 5 is 2.8. I can't be bothered using a ruler. You should. 14 divided by 10 gives us 1.4. So hopefully you've made a much better job of drawing them than I have. Number 17, algebraic fractions. They've all kind of got things in common, but yeah, the good news is 2x is a factor of 10xy. Also, 5xy is a factor, which means each of these 3 fractions can be written with a denominator of 10xy. The first term doesn't have to be changed. The second term, well, 2 needs to be multiplied by 5, and we need a y. We've times the bottom by 5y, we times the top by 5y, and on the third fraction, the bottom has doubled. We need to double the top. Now notice that, because I'm just going to be careful, that negative is in front of the whole fraction. So actually, it's a negative 2y, which needs doubling, but it's negative 7x. That's positive 7x. That also needs doubling. And that's just one of those things I prefer to do, because now when we combine them, you should always take care with minuses, but mine's already taken care of. 6x minus y plus 5y minus 4y plus 14x. As you can see, what actually happens is minus y minus 4y is minus 5y. They disappear. The y's, they all go away. On the top, we've got 6x's, 14x's, 20x. As you can see, firstly, the x's disappear, but not only that, 20 divided by 10 is 2. And after all that, that's all they wanted. K is an integer, k is 2. It's nothing more than 2 over y. Number 18, a little bit of a strange one, but only worth 3 marks. Firstly, they've told us that BA equals BC. Them two lines are the same. Next, B to O, O to A, O to C, they are all radii. And that's now the key step. Side, side, side. These two triangles are identical. They are congruent. Now, if they are congruent, whatever angle that is the same. And if they are the same, they are each accounting for half of angle ABC. And that's the crux of that question, showing that they are congruent triangles and using that as logic. As always, I've written them out in full, and my model answers, feel free to go across and check them out. But as long as you verbalise, as long as you write down what I've just verbalised, you'll be fine. Congruent triangles means identical angles, means half of the whole. Number 19, errors and bounds. I know people aren't a huge fan of these because they just take the time, but I would argue do that exact thing. Take your time with them. Do not rush them. It's worth 5 marks. Take 6 or 7 minutes. It's fine. First of all, let's look at the W. If something's been rounded to the nearest 5, you go up and down by half the rounding amount, which means we add on 2.5. 437.5, 432.5. Now let's do A. It's 2 significant figures. That's the first decimal place, or in other words, nearest 10 pence. Let's go up and down by 5 pence. 9.85, 9.75. Same for C. Up to 2.55, down to 2.45. It's one of them where it doesn't ask you for the upper bound or the lower bound. It's really asking for both by considering bounds. That means we want the upper bound of t as well as the lower bound. This is where your logic comes into play. If I want to make t as big as possible, I should pick the biggest possible w and divide it by the smallest possible denominator. How is the number on the bottom as small as possible? I need smallest a minus biggest c. And that's what you need to be typing in your calc. 437.5 all over 9.75 minus 2.55, giving you approximately 60.76, and so on. Let's reverse that logic. If we want t to be as small as possible, we want smallest w divided by biggest bottom, and the biggest denominator is by having biggest a take away smallest c. That makes this sum 432.5 on your calc divided by 9.85 and 2.45 subtracted, and again approximately giving us 58.445-ish. As you can see, it says by considering bounds, calculate t to a suitable degree of accuracy. What that means is you're looking for where these two numbers are basically the same. 60, well, if you round both of these numbers off to two significant figures, they both equal 60. That's the answer. They're kind of converging at 60. They both agree. To three significant figures, they don't. That's 60.8, that's 58.4. They don't agree to three significant figures. And one significant figure, a little bit too vague, because two sig figs is where it's better. All right. It would be one sig fig as well, really, wouldn't it? 60. Yeah, I suppose so. But I'll go with two significant figures. They both round off to 60. And that's the logic we're looking for. Number 20, we've got a bit of three-dimensional trigonometry going on. So what we're told at the top, solid pyramid, and ABC is an equilateral triangle. Okay, great. M is the midpoint. You could obviously put a 1-to-1 ratio on there if you wanted to, but it's fine. You could put the notches. I'll leave it at that. F is the point on MC such that it's 1 to 2. That's a third of the line, and that's 2/3 of the line. That'd be fine as well. The vertex V is vertically above, so I'm going to draw that in. That being vertical is giving us a right angle there. Okay, that's the first key step for me, because that starts to give you your first, that's horrible, but who cares, your first right angle triangle. We're told that V to F is 8. That's that vertical line, VF is 8. We're told that VCM is 52. Bit awkward there, but a bit better to look at here. What that means is it'd be nice, because work out the side length of the equilateral triangle. Well, to work out that distance there, you're going to need to know some distances elsewhere. That's why we're looking for that particular value, the value of F to C. I'll just call it X. Looking at this triangle, we've got from 52, 8 is opposite, x is adjacent. We kick off with a bit of tower. We're wanting the adjacent, which means we need to do opposite divided by, what's that? The tan of 52. We're getting approximately 6.25 centimetres. But that's not the whole distance C to M. That's only part of the distance. To get the whole, we actually need to multiply it. We need to add on half because it's worth 2/3. We want to add on, we want 3/3. We need to add on half. Best way to add on half to something is times it by 1.5. Gives us 9.375-ish. What that means is, if we do a redraw, let's now look as a plan view right down on top of this equilateral triangle where that's C, that's B, and that's M, the midpoint. We are told that the distance CB and the distance AB is the same. We're told it's an equilateral triangle, but that M is the midpoint, meaning that's half the size. And we've got the 9.375 in there. Yes, folks, it's now a Pythagoras question, because M being the midpoint makes that a right angle. Off we go. The hypotenuse squared and the not the hypotenuse squared, sorry. The shorter side squared and added to the other shorter side squared should be giving us the hypotenuse squared. Y over 4 all squared. I said the wrong thing. Y over 2 all squared is y squared over 4. 1y squared minus a quarter y squared gives us 3/4 y squared. We can now unpick to find the value of y. Stick the 9.375 squared into your calc, times it by 4, divide it by 3. You should be getting 117.1-ish. But that's your value of y squared. We need to square root that 1 decimal place. We end up on 10.8 centimetres. Number 21. One of those horrible questions that if there isn't a diagram, it's usually a good idea to draw one. Feel free, because at the end of the day, what you're needing to do, if you're told it's a right angle, that means the right angle is at R. What do we know about right angles? It means the two gradients, when they multiply, equal -1. Or let's rephrase that. Whenever you've got two lines, 2 points, if you find the gradient of one of them, the gradient of the other, one is the negative reciprocal of the other. Let's do that. So you could have drawn a diagram, it might have helped you picture it, but ultimately it's gradients we're looking for. Let's find them. the gradient of P to R, as you'll know, change in Y's over change in X's. Change means difference. Difference means subtract. Now, the order doesn't matter as long as you maintain the same order. So because I'm going from P to R, I'm going to do 5, that's the Y coordinate, minus the Y coordinate of R, all over the X coordinate of P, minus the X of R. Being a bit slow in my pen, come on. There we go, that'll do. That is a K, trust me. Let's tidy it up. On the top, we have 5 minus 3, and we have negative K. And the bottom, well, we can just leave that alone for now. Let's now do gradient of R to Q. That means Y coordinate of R, which is K plus 3, minus the Y coordinate of Q, minus 6. Again, we'll tidy it up in a bit. On the bottom, Y coordinate of R is K, and we subtract the positive 6. And again, let's tidy up. K plus 9 over K minus 6. And as I waffled at the start, these two things aren't equal. They're only equal if you flip and negate one of them. Doesn't matter which one, it will all work out the same. I'm going to leave the 2 minus K alone. I'm going to leave the gradient of PR alone. What I am going to do is first of all flip this fraction upside down, but then multiply by -1. Now, when you want to multiply something by -1, you could times the bottom by -1 or the top by -1. Again, doesn't matter, just don't do both. I will times K minus 6 by -1, meaning the negative 6 becomes positive 6, the positive K becomes negative K, and we leave the K plus 9 alone. And now it's just an algebra question. The coordinates have gone. We need to multiply both sides by each denominator. In other words, take the K plus 9 up there, take the minus 4 minus K up there. 2 minus K and K plus 9 will be expanded shortly. 6 minus K and minus 4 minus K again will be expanded shortly. Left hand side, again, loops, grids if you want to, it's entirely up to you. Here's what I get: 2 times K, getting 2K plus 18 minus K squared minus 9K. Right hand side again, loops any order you want, minus 24 minus 6K plus 4K plus K squared. Let's collect our like terms, simplify and all that malarkey, but ultimately get 0 on the left hand side. We first of all, let's add a K squared to both sides. When you simplify your K's on the left, K's on the right, and bring them to the right hand side, you get 5K. Because what have we done with 2 minus 9? We've got minus 7. Add 7K to both sides. There we go. And for the numbers, left hand side, we need to get rid of the 18. We subtract 18 from both sides. As always, when you get to this stage, if you prefer the quadratic formula, go for it. A is 2, B is 5, C is minus 42. But it does factorise. If you want to practice the AC method, now's your chance. I've already done it, so I'm not going to do it again. 2k minus 7, k plus 6. Two answers for k. Change the sign. Change the sign and divide by 2. A lot of work for that question, but well worth sticking with it. On we go. For number 22, we've got red and yellow counters. The first thing is, though, don't read beyond there before doing some maths. If we've got only red and yellow, and we've got 3/5 to 2/5, we can actually write a statement, a mathematical equation linking these two things together. We can say that R is equal to whatever Y is, in this case 2, but it needs to be multiplied by 1.5. R is a half bigger. In other words, R is Y times by 1.5. But obviously a better way of writing that. So there's a little equation that is going to come back to play in a bit. Next, Sophie takes at random two counters, probability of the same colour, that's red red, yellow yellow, equals 41 over 80. Sometimes it's worth making a note of that if it gives you somewhere to start. Well, what is the probability of getting red red? Well, red red, the first one, the first counter being red, we actually already know. It's 3/5. But what about the second counter being red? Because there's no guarantee that it's actually 3. We can't just take away 3. Sorry, we can't just take away 1 from 3 to get 2. There's an unknown number of reds. We're going to have to write it like this. The number of reds goes down by 1. The number of counters also reduces by 1. But same logic, the number of counters ain't 5. It's a multiple of 5. It's not necessarily a multiple of 8. It's a multiple of 80, but it's not necessarily 80. Could be 800 or 8,000. How do we get the total? The total number of counters right at the very beginning is the number of reds plus the number of Ys. That's going to be our expression for red red. Same logic for yellow yellow, but it's now 2/5. Take the number of yellows minus 1, and the number of counters in the bag will actually be the same. Moving this forward, we can combine these two. They have the same denominator. They're all over 5 lots of R plus Y minus 1. So on top, let's do top times top here. That's 3R minus 3. And top times top here, 2Y minus 2. Well, we've now got horrible simultaneous equations. I'm not a fan of subbing in while we've got them as fractions. Let's level them off. I'm going to multiply both sides by 80. So 80 times 3R 80 times 2y minus 3 minus 2 is minus 5 times by 80. And to multiply both sides by 5 and these brackets, let's not expand the brackets just yet. Let's just take it up here. 41 times 5 is 205. Lots of the bracket. We are going to expand it, but no point in writing it all out. So again, don't forget, I'm going to just scroll down a bit, but we have got this r equals 1.5y, because what we're going to do, we're going to expand the right-hand side and collect like terms, so we get 0 on the right. So 205r, subtract that from both sides. 205y, subtract that from both sides. Minus 205, add 205 to both sides. And now's that step. I am not only going to, they're all in the 5 times table obviously, I'm going to divide everything by 5. This is 39. This is minus 9y. But I'm actually going to divide this by 5, so we get 7. But I'm now going to replace the r with the 1.5y I waffled about right at the start. This means we can now solve. Adding 39 to both sides gets that out of the way. Grab your calc. 7 lots of 1.5 is 10.5, but then minus 9 means we've got 1.5y. And now if we divide both sides by 1.5, 39 divided by 1.5, y is 26. After doing all that work, always make sure you've answered the question. Yep, work out the number of yellow counters in the box. Number of yellows is 26. Well, I've got to say, not a bad paper overall, but right near the end, as you can probably guess, 2 or 3 pretty tricky questions. But hope that's helped, and I'll see you on the next one.